Here we've taken 3 samples in 1/1000th of a second. That's 3,000 per second, or a sampling rate of 3 kilohertz. What would the reconstruction of these 3 pulses look like? Not much like the original. Let's try 5 kilohertz. That gives us 5 glimpses of our tiny piece of signal. Again, reconstruction isn't much use, though it's better. With 8 samples, things look very promising. In fact, there is no point at all in sampling more rapidly, at least with telephone quality speech, which contains no signals higher than 4 kilohertz. It's a very important principle in communications engineering that to work properly, sampling must take place at a rate of at least double the highest frequency present in the signal. One by one, the samples can be fed to a circuit which assesses their height. Let's suppose we have a simple circuit which can give each pulse's height and number from 0 to 7, 8 steps altogether. The first pulse to arrive is bigger than 6, but smaller than 7, so our circuit labels it 6. The next one just reaches the level of 5, so it is labeled 5. The next one is bigger than 4, but smaller than 5, so our circuit labels it 4. Eventually, our 8 samples become a string of 8 numbers, and now the coding can come in. Morse code can be used to send numbers by a series of dots and dashes, but the code used for speech communication is binary, just the same as is used in computers. Any number can be represented by a combination of noughts and ones. In electrical terms, a pulse represents a 1, no pulse represents a naught. The conversion of numbers into binary code is the last stage before transmission. And this again is done by an electronic circuit. Before transmission, the signal has gone through 3 basic processes: sampling, quantization, which is the correct term for the measurement of pulse heights, and coding. The system looks like this. This method of speech communication is known as pulse code modulation, PCM. Let's go back to our rotating switch. Once we've established that we need only send samples of a signal, what can we do with the gaps between the samples? Why not send samples of other signals? Look at 2 signals, red and green, being sampled alternately. The samples can be transmitted along the line in succession without interfering with each other. Likewise, coded samples, the basic binary digits of PCM, can be interleaved in this way and decoded into the original samples. This method of transmission is called time division multiplexing and is an important principle in the electronic exchanges which are used to switch pulse-coded messages.